Hey, iqkid here to talk about the gas law. So today we're going to be covering the ideal gas law. So just to review real quick, there's Boyle's law, which relates volume and pressure, Charles' law, which relates volume and temperature, Avogadro's law, which relates volume and the amount in moles, and then the ideal gas law, which relates all of them. Okay, so first let's look at the basic gas properties. So the basic gas properties are pressure, which we represent with a capital P, volume, which we represent with capital V, temperature, which we represent with capital T, and lastly, the amount in moles, which we represent with a lowercase n. So all of these properties are interrelated with Boyle's law, which, as I said before, or as I showed before, it deals with volume and pressure. So volume is inversely proportional to the pressure. Charles' law, which has that volume is directly proportional to the temperature, and Avogadro's law, which has that volume is directly proportional to the amount in moles. And for Boyle's law, this is at constant temperature and the amount in moles. So constant T and N. This one is at constant P and N. So it's just that the other two properties are constant. So for this one, it would be at constant P and T. Okay, and so the ideal gas law, to get into that, deals with all of these properties. So volume is proportional to the amount in moles and the temperature in a direct relationship. So it's just like this. So the volume is directly proportional to the amount in moles and the temperature, and inversely proportional to the pressure. So then this symbol means proportional. So this means that basically the ideal gas law is the other three gas laws combined. So we can represent the ideal gas law with this equation. V, the volume, is equal to R N T over P. So in this we have R, which is not one of the gas properties, it's actually the ideal gas law constant, and this is what it's equal to right here. So we commonly rearrange this equation to be pressure times volume is equal to the amount in moles times the ideal gas law constant, and then times the temperature. And the units of measure right here are what you want to use, or what you want to convert into when solving a problem with the ideal gas law constant, or with the ideal gas law. Okay, so now let's talk about standard temperature pressure. So STP. So standard temperature pressure is 0 degrees Celsius, or 273.15 Kelvin. So we commonly say 0 degrees Celsius, but if you actually use the ideal gas law constant and the ideal gas law, then you have to use Kelvin. And then also at 1 atm. So its standard pressure is 1 atmosphere, and standard temperature is 0 degrees Celsius, or 273.15 Kelvin. And something to take note of is that gases at high pressures and low temperatures tend to behave less like an ideal gas. So the closer the gas is to standard temperature and pressure, the more it behaves like an ideal gas. Okay, So now let's look at an example. In this example, a 1.25 gram sample of CO2 is contained in a 750.0 milliliter flask at 22.5 degrees Celsius. What is the pressure of the gas? So step one is to convert. So we need to convert grams of CO2 into moles. So 1 mole of CO2 divided by the molar mass is 42.01 grams of CO2. And then that will give you 0.028402638 moles of CO2. Okay, and then and that's not taking into account sig figs. That's the raw number for calculation purposes. And then the other thing we need to convert is 750.0 milliliters times the conversion factor is 1,000 milliliters in every 1 liter. So then we get 0.7500 liters. And we have to do that, if you remember, because of the ideal gas law constant. It says we have to have it in liters, so that's why we converted. And then moles, and we have to have moles, so we had to convert the grams. And then we also have to convert the 22.5 degrees Celsius into Kelvin. So 273.15 equals 295.65 Kelvin. And again, we had to convert into Kelvin because of the ideal gas law constant. Okay, so then in step 2, we're going to write the formula. So we're just going to write P, pressure times volume, equals the amount in moles times the ideal gas law constant times the temperature. So PV equals nRT. Okay, so now let's move on to step 3, which is to plug and chug. Okay, so in step 3, we're just going to take the equation PV equals nRT and plug in. So we are trying to find the pressure. We have the volume is 0.7500 liters. That's equal to the amount in moles, which is 0.028402638 moles of CO2. And then multiply that by the ideal gas law constant, 0.08206 liters times atmospheres over moles times Kelvin. And then we need to multiply that by, so I'm just drawing it down here, so times, because I ran out of space, times 295.65 Kelvin. Okay, so that would be equal to P equals, so we're isolating the pressure, the unknown, so P equals 0.028402638 moles of CO2 times 0.08206 liters times atmospheres over moles times Kelvin, and then multiply that by the 295.65 Kelvin, and then all divided by 0.7500 liters. Okay, and then we can plug that into our calculator and get the pressure is equal to 0.918769938 atmospheres. So we can see that moles cancels there, liters cancels there, and Kelvin cancels there, which just leaves us with atmospheres. Okay, so that's not our final answer though, because we need to take into account the significant figures. Okay, so then our pressure is 9.19 times 10 to the negative first atmospheres. And that's our final answer. Okay, so now let's do another example. In this example, we are going to deal with standard temperature pressure, or STP. So in this example, it says to calculate the volume of 1.00 moles of an ideal gas at STP. So step one is to convert. So we need to convert our degrees Celsius, 0 degrees Celsius plus 273.15 is equal to 273.15 Kelvin. So we didn't really need to do that, but just to remind you that that's what's commonly given for standard temperature pressure, and we need it in Kelvin. Okay, so then step two is to write the formula. So PV equals nRT. Nothing changes with the formula. It's still the ideal gas law. Okay, and then step three is to plug and chug. So PV equals nRT. So then the pressure is standard pressure, so 1 atm. And that's because it's a definition, significant figures don't matter with that. So then times the volume is equal to 1.00 moles, that's the given amount, times 0.08206 liters times atm over mole times Kelvin, and then multiply that by 273.15 Kelvin. So then the volume is going to be equal to 1.00 moles times 0.08206 liters times atm over moles times Kelvin, and then multiply that by 273.15 Kelvin, all divided by 1 atm. And then plug that into a calculator, and you will get 22.4 liters. So that's your final answer, because that is correct sig figs. Okay. And something to take note of is this value right here. That's actually something you can put in your notes. 1 mole of any gas occupies approximately 22.4 liters, so that amount, at standard temperature pressure at STP. So that might be a helpful value. Now you can apply this problem and just for any value, basically you just use the ideal gas law, the equation. Okay, I hope this helped. If you have any questions or need help with anything, or even completely unrelated stuff, I'm happy to help. That's what I'm here for. Yeah, so also if you have a suggestion for my next video, you can contact me through the comment section or through the email in the description, or on at my online site, which I will post in the description. Thank you. Have a wonderful day. iqkid signing off.